So the material balance for the tank 1 and tank 2 we can write it as A1 dH1 over dt equals to Qi minus Q1, which is here equals to Qi minus 1 R1 H1. Same with the tank 2 A2 dH2 dt equals to Q1 minus Q2 equals to Q1 minus 1 over R2 H2. This is two equations for the material balance of tank 1 and tank 2. So I label it as equation 1 and equation 2. So now we will introduce the derivation variables and we will do the Laplace transform for the equation 1 and equation 2. So now it becomes derivation variables and also the Laplace transform. So these first equations will become as, after derivation variable a is the a1 dh1 with capital of H to indicate we already introduced the derivation variable equals to Q I, indicate the variation variable with the capital Q, minus 1 over R1 H1. Okay, so now this one is become equation number 3. Same with the second tank, which is A2 dH2 over dt equals to Q1 minus 1 over R2 H2. Okay, so this one's become equation number 4. Okay, then we apply the Laplace transform for both of the equations. Then what we get is A1 S HS, which is equals to QIS minus 1 over R1 H1 S. And same with the equation 4 to indicate the tank 2 A2 S HS, okay, which is equals to Q1 S minus 1 over R2 H2S. Okay, so please pardon me this one, I like to write H1 and here is H2. Okay, let's continue with these equations. This equation and these equations, we can rearrange it to make sure it in the form of the standard form of the first order system. So for these equations, I rearrange it as A1 S H1S plus 1 over R1 H1S equals to QIS. We just rearrange it. Okay, and we try to factorize this. A1 S plus 1 over R1 HS equals to QIS. Okay, now I try to rearrange it in the transfer functions in the form of output with the input, which is this one H1, yeah, H1S equals to over QIS equals to 1 over 1 A1S plus 1 R1. And we try to arrange this in the form of standard form of the first order, R1 over A1 R1 S plus 1. So this one is the form of the first order. Okay, now go for the second time, which is have the similar way on how we did for the first step, which is A2 S H2 S. Okay, bring it here to the left hand side, R2 H2 S, which is equals to Q1S, and then we arrange it until we get the same as what we did for the tank one. So what we get now is H2 S Q1 S equals to 1 over A2S plus 1 over R2, which is here we rearrange it, R2 over A2 R2 S plus 1. So we get this in the form of standard form of the first order system. Now we got the standard form for the H1 over Qi and also H2 over Qi. So now Q1, sorry. Now we move to on how to find the transfer function for Q2 over Qi. Why is Q2 over Qi? So if we look again to the diagram given, we have two tanks, and then we have, which is the inlet is Qi, and this is non-interacting tank, and then we have the outlet of Q2. That's why we want to find what is the transfer function of Q2 over Qi. This one in the form of derivation variable. So what we can draw to explain this in the block diagram. So let's say I have this block diagram. So I know that what is going inside the system is QIS, and this is non-interacting, and then from QIS here I got the level H1S, okay, which is here is Q1. From the Q1 here, what I got is the H2S, the height, and then as the outlet as Q2. Okay, this one in the form of the block diagram. So I can write this block as a G1S, G2S, G3S, G4S, all in S domain. So for the total transfer function for this system is GS equals to Q2S over QIS. In order to get Q2 over Qi, what I need to do is to use the characteristic or the multiplication, okay, of the transfer function. So it's become G1S, G2S, G3S, G4S. So this one I can write as because a G1, okay, is the output over the input here, so I can write as H1s over QIS. Then for the G2, done for G1. Now for G2 is Q1s over H1s. Then for the G3, H2s over Q1s. Then for G4, Q2s over H2s. So if we try to cancel out these items like this, H1, H1, H2, H2, right? Q1, Q1 means I still get Q2 over Qi. Okay. So in the previous derivations, we already got what is our Hi over Qi, and also what is our H2 over Q1. Okay, for Q1 over H1 and also Q2 over H2 is given as Q1 equals to 1 R1 H1, and for the Q2 is equals to 1 over R2 H2. So when we apply derivation variable and also the Laplace transform, so what we get for Q1 is Q1 S equals to 1 over R1 H1S. Okay, so if I arrange this one to become as Q1 S over H1S, what I get is 1 over R1. So it's same with the Q2. So after the derivation variable and also the Laplace transform, what I get is Q2 S over H2S equals to 1 over R2. So this one will explain this Q1 over H1 and also Q2 over H2. So now we can substitute all of these equations inside these equations. So when we do the substitutions, what we get is the GS, which is equals to, for H1 over Qi, if we refer to the previous derivations, the form that we get is R1 over A1 R1 S plus 1. And then for Q1 over H1 here is 1 over R1. Same with H2 over Q1 from the previous derivations, what we get is R2 over A2 R2S plus 1. Then the last one for Q2 over H2 is 1 over R2. Okay, so if I rearrange everything here, okay, so what I can get is this one is already cancelled, this one already cancelled. So what we get is 1 over A1 R1 S plus 1 times A2 R2 S plus 1. So from here it's very clear to indicate that this non-interacting time here, when we do the derivation of the transfer functions, what we get is a second order system. Okay, so thank you so much.